Okay, students, today we are going to model a thread gauge. It's really basically a tool that you can quickly check the diameter of your screw, the number of threads per inch of your screw, and I'm going to go over all that thread nomenclature pretty soon. But this is the next project we're going to make in the MAC 161 class. So we got time, but right now you're in the process of making the T-slot cleaner. So, but this is project number 2. And I'm going to show you how to, again, create a 3D model and then a drawing of the thread gauge along with what they call a hole table, which makes things much easier, as you will see, as far as when you have a leader pointing to a hole and the leader has, let's say F1, I can go to the table and say F1 has an X diameter of 0.38 and a Y diameter of 1, and the thread size is 1/4 28 UNF-2B. Well, Mr. Morris, what does that quarter mean? The quarter means the diameter of the screw. What's the 28 mean? The 28 means 28 threads per inch. So for every inch of the screw, you have 28 threads. What does UNF? UNF stands for Unified National Course. And then 2 means it's a threaded hole, or actually the classification of fit. And B means it's an internal hole. If it was an A there, that's external thread. We'll talk about that later. But right now, the main thing we need to do is we need to create a model of this. And from the model, we're going to make a drawing. Okay. So go ahead. I already have my inventor open. So that's what I'm going to do. I'm going to go ahead and share my screen. And give me just a second. So what you see on the screen right now is what we're going to model and then make a drawing. This is the drawing. And I gave each one of you a handout showing exactly the same thing in case you get lost, okay? And I'm going to take it very slowly. And we should have a lot of fun with it, okay? It's really neat when you're able to make 3D models like this, and then eventually send it to a CNC machine, the data, or even a 3D printer, okay? All right, so without further ado, I'm going to close this one out. This is the 3D model of it, okay? And to show you, if you zoom in, you can see the threads, right? The threaded holes to accept a screw. And then we left you a little space here so that you could stamp your initials in it later. So you know it's going to be something you could take home. You can actually make a keychain out of it if you want to. Put a big hole here and make a keychain. But you have to have somewhere stamp your initials. All right. All right. So I'm going to close this out. Just close it off. All right. So when you open up Inventor, this is what you should see. All right. So I'm going to go to New. So select New. I'm going to go through this very slowly like I have with the other videos. If your screen looks like this, for example, so where's the English and the metric? And don't panic. It just means you need to expand. Click on this arrow and expand your choices. There's English right there. This is an English part. And yes, we are going to do some metric parts in here. So select English. And then come over here. We're going to create a 3D part. So IPT stands for Inventor Part File. It's the file extension, meaning Inventor Part. And it's in inches. So we're going to click on this icon. And we're going to come down here to the lower right-hand corner, and you're going to select create. And it's going to do its thing for a minute here. Okay. Now you got a blank screen here. You have a menu, your menu items up here. The first thing we need to do is select Start 2D Sketch. So top left-hand corner, select Start 2D Sketch, and then select Start 2D Sketch again. When you do this, and I've pointed this out in several videos, you're going to get 3 planes. You have the XY plane, you have the YZ plane, and you have the XZ plane. And they all intersect at the origin, right? And you have to pick a plane that you want to create a sketch in. Now, with Mr. Morris, 99% of the time, I can do most of my work in the frontal plane. So the XY plane, excuse me, is the frontal plane. So I'm going to click on this plane right here. Click on it. And when you do, what do you see? Down here in the lower left-hand corner, you see the green arrow, which represents the Y-axis. The red arrow represents the X-axis. And we have the Z-axis coming out towards us. That's the blue arrow. And again, over here, if you look here, this is the what? This is the Y-axis, and this is the X-axis. Now, again, we've talked about the scroll wheel. If you hold the scroll wheel down and move your mouse around, you can pan. You can also rotate your scroll wheel to zoom in and out. Now, the overall dimensions of this part here is it's 4 inches long and it's 1.5 inches tall. See that? It's 4 inches long and 1.5 inches on your handout. So that's my starting point. I'm going to make a rectangle. So I'm going to go to rectangle right here, click on rectangle, and come down and select rectangle 2-point. Now, I'm going to move my cursor to the center. What happens when it moves to the center? Turns green, right? It's going to snap to the center, turns green. As soon as you see that, click, and we're going to drag out a rectangle. Just drag it out. No clicking, just drag out a rectangle. It's wanting some information here. It's wanting us to enter the length dimension and the height dimension. So our length dimension is 4. I'm going to type in 4, and then I'm going to hit the tab key. And don't worry if it goes off the screen. We can fix that. We're going to enter a dimension of 1.5, and we're going to enter. Then we're going to do a right click now with your mouse, select OK. Mr. Morris, my geometry has disappeared off the screen. Rotate your scroll wheel and then pan, hold down the scroll wheel and move over like that. All right. So everyone should have a 4-inch by 1.5 inch tall model. So give you a second to catch up. You always have to start off with a 2-dimensional sketch with your 3D part. And we're going to add some depth to it. Okay. All right. So hopefully everybody is with me. If not, that's the beauty of the videos. You can watch the video again and go back and catch up with us if you fall behind. I'm going to finish the sketch here and then select finish sketch again. And again, it goes off the screen. Just rotate the scroll wheel until you can see it, and then you can pan. Remember, you have to hold down the scroll wheel and move it around. So we're going to add some depth to this geometry. Go to extrude. And the default, it always wants to add 1 inch. Well, I don't want it to be 1 inch. And also it defaults in the positive Z direction. If you look down here in the lower left-hand corner, the UCS icon, the blue arrow represents the positive Z direction. Well, first of all, I don't want to go in the positive Z direction. I want to go in the negative Z direction. So flip it. There's a reason for that a little bit later on, because this is going to be this is going to be the Z0 plane here, the Z0 plane. And we'll need that when we get into CNC machining. The distance here that we're going to make this, or the thickness rather, is 1/4 inch, 0.25. So it's 1/4 inch thick. Okay. And we're going to select OK. So this is what our plate is. Now what we want to do is we're going to start laying out these holes one at a time. We're going to do A1, B1, C1, D1, E1, and so forth. We'll do it in that order. So there are easier ways to do things in Inventor. Mr. Morrison, why are you doing the hard way? Because I teach the hard way first and then the easy way next. Okay. So we're going to go to Start 2D Sketch, Start 2D Sketch, and I'm going to click on this face, which is a plane. All right. Now, up here on your menu bar, you have these points. See, it says point here. Click on point, please, and then come over to your plate. And I want you to just click roughly in this location, arbitrary, locate, click, do a right click now, select OK. So you'll see a little point there. What we want to do is we want to dimension that point, and the dimensions are going to be, go to the dimension tool. We're going to click on this edge, and we're going to click on the point. We're going to drag our dimension down. We're going to click. And now this is where it gives us a chance to enter the actual dimension, which is 0.375. So Mr. Morris wasn't too far off. Enter. Okay. Now that's just one dimension. We have to add another one. We are still in that mode because this icon is depressed. So I'm going to click here, drag your dimension off the part, left click. So left click means click, a right click. I'll say right click when I hit the right mouse button. I'll just say click when you hit the left mouse button. And this is a dimension of 0.422, and you can see that on your the handout I gave to you. I'm going to click on the check mark. All right. Now, we have our location for our first hole. Let you have a breather here for a second. Hopefully you're still with me. All right, we're going to finish the sketch by clicking on this check mark here. So finish. All right. Now this is something new. This is really the new, you've done a lot of this here so far, but what you haven't done is use the hole feature. We have used the circle command to make a hole, but today we're going to use the actual hole feature. On your menu bar, select hole. And you might have all kinds of things pressed here. We're going to take one at a time. The first hole, A1, is a threaded hole. So look where it says hole and come over to the third one is threaded. By the way, the word tapped means threaded hole. The word tapped means threaded. We don't want a seat. We don't want a counter bore or spot face or a countersink. I just want none. Select none. And then I want you to come down. It is the type of thread we're going to make threads. So the American National Standards Institute Unified Thread Screw Thread. The size of this A1 is 1/4 20. So arrow down here, arrow down, and I want you to find 0.25 right here. When you select 0.25, now you have to give your thread designation. What does 1/4 mean? The 1/4 means the diameter of the screw that's going to go in that hole. It's 1/4 inch. How many threads per inch does the screw have? It's a unified national course. And no, unified UNC does not mean University of North Carolina, as some of my students have put on quizzes in the past. So I'm going to select 1/4 20 UNC, and the classification of fit, it is a 2. And then by the way, the best classification of fit is usually a 1. Okay. So for the letter B here means that it's an internal hole. If it was A, it's external threads. So it's internal. We also want the threads to go to full depth. We want to go to full depth. Okay. And everything looks good. Select OK. And if you scroll in, congratulations, you made a hole with threads in it. Were you successful? All right. Now we're going to repeat that process several times. By the time we're done, you'll be an expert at it. That's the whole point of it. Go to Start 2D Sketch, Start 2D Sketch, and click on this plane right here. All right. Now we're going to come up here to where it says point. And I want you to, now here's a little trick. You can hover around the, not snap, but hover to it, and you can pull out an inferred line. An inferred line is a ghost image of a line. It's not really there. It is, but it's not. Click. Do a right click with your mouse, select OK. Now we have to dimension that point. Go to your dimension tool right here. Click on this edge, click on the center point, drag your dimension off the part, click. What should this dimension be based on the drawing? Pardon? 0.938. I'm going to select the green check mark. Now, remember earlier when I hovered at the center of the hole? Notice I don't have to change anything because I hovered around the center here when I made that point. Watch one more time. I just come here, hover around the center point. It's 0.422. I don't have to do anything except accept it. And now we have properly located the center of the next hole. Select finish. Finish the sketch. Now we get out of the sketch mode and we get into the 3D mode. Click on hole. Now notice it automatically uses the same hole that you previously did, but we don't want to use that size hole. We have a different size this time. It is a threaded hole. So we do want this. It is a threaded hole. It does not have a seat. In other words, it's not a counter bore. It's not a spot face. It's not a countersink hole. But the size is different. If you go to B1 on the table, it says it is a 5/16. So come down here, and what is the decimal equivalent for 5/16? Y'all punch in your calculator. Tell me what the decimal equivalent is for, because we got to start learning.
3125.
point 3125, right? 0.3125. And then this is a check. Look, if you get it wrong, you can see we're correct because there is a designation. The diameter is 5/16. Do we have the right number of threads? It says 18. Is that what our table says? B1 says 5/16, 18. What is UNC? Unified National Course, right? It's a course thread. Because we have fine threads, we have coarse thread. This is a coarse one. We want to go to full depth. We want to go to full depth. By the way, we didn't talk about direction last time. Right is always the default, right-hand threads. You know, when you turn a screw into a hole or into a nut, you turn it clockwise because that's a right-hand thread. But you know, they have some screws you have to turn counterclockwise. That's a left hand. Those are oddball threads. They do have turnbuckles come to mind. You know, sometimes you have a turnbuckle where you have a right hand and a left hand thread. All right. So I'm going to say okie dokie here. All right. And if you look, I have two holes here now. See? Two threaded holes. All right, now we're going to go to start. And look at my browser format, please. If I want to change anything about hole 1, I just expand this. There's the sketch. I can right click on that and edit the sketch. If I want to change anything about hole 2, again, I could just click on this or click on the feature. You can also click on the feature if you want to change something about the thread size and stuff like that. So start 2D sketch, and click on this face. I'm going to do the same thing I did last time. I'm going to point. Now look, see how I'm hovering? I'm hovering. I didn't click. I'm hovering. And I'm going to drag out roughly about that far. Click. Do a right click. Okay. Now we need to dimension this. Go to dimension. Click on this edge. Click on this, the center mark or center point. Drag it down. Click. And what is this dimension based on the drawing I gave you? 1.562. And I'm going to select the green check mark. Now watch this. If I come in here and I put this dimension in here, it's fine. Select OK. Because I hovered and I stayed on the center line. Give you a breather for a second, catch up. This will be our third hole out of 10. We got quite a few to make. I'm going to select the finished sketch here. And then I'm going to go to hole. And we want a tapped hole. That's what we have. As far as, again, we don't want any seat. This is a C1, means 3/8. So 3/8 is 0.375. So select 0.375. And it says it's 3/816. Is that the right thread size? Based on our drawing that I gave you. Is that a yes or no? It's yes, right? It's a right-hand thread because you turn it clockwise to screw it in. The full depth, which means the full thickness of the plate. And we're going to select OK. All right. Go to Start 2D Sketch. Start 2D Sketch. Click on this face. Again, go to Point. Hover. You're going to hover. I'm gonna guess it to be about right there click, do a right click, okay. Now we want to go to dimension. I want to click here. I want to click here. I'm going to drag my dimension down, click. What is the dimension for the fourth hole? 2.250, right? So 2.250. I'm going to select the green check mark. I'm also going to do the height dimension. I don't have to do anything because I did the hovering trick, right? And I'm going to finish the sketch here. So select finish sketch. And we're going to go to hole. And again, we want it to be a threaded hole. And we want no seat. Now, this time, what size is the diameter for D1? 1/2. Which is, we got to come down a little bit, select 0.5. What's the number of threads per inch? If 1/2 is the diameter, how many threads per inch? 13. What does UNC stand for? Unified National Course. The classification of fit is a 2, and B means is internal threads. Now, notice the thickness of the part is fully threaded. So the threads go the full depth of the hole. That's what that means. See, if I turn off the full depth, look what happens. You don't have to go all the way down. But I'm going to turn the full depth on, just like before. And we're going to select OK. Now, now this is a good time to realize that Mr. Morris made a slight mistake. And it's okay. Those mistakes are good because it helps you to relearn stuff. Look at the drawing that I gave you. Are all 5 holes on the same center line? They're not, right? Y'all were being nice to me, didn't say no. The larger holes are 0.422 from the edge. The larger, not the smaller holes that we just did. So, Mr. Morris, how do we find that out? Well, go back and look at A1, B1, and C1. And then tell me what it should have been. 0.5. 0.5, the D dimension, or the Y, excuse me, the Y dimension. The Y dimension for A1, B1, and C1 should be 0.5. So you panic. Mr. Morris, how do I change that? Look here. Look how nice this is. Go over here to where it says hole 1. Expand it. Do a right click on sketch 2 and edit the sketch. And all you need to do is double click on this dimension right here and make it 0.5 and enter. Finish. Watch this hole move. It moved up. Okay. You don't believe me? Look here. See how it moved up. These two are still located in the wrong Y dimension. So how do we change it? Look, I'm going to close this or collapse this. I'm going to expand hole 2. I'm going to right click on the sketch 3. I'm going to edit the sketch. And I'm going to make this, double click on the dimension and make it 0.5. Hit the green check mark. Finish the sketch. And now that hole got moved up. I got one more hole to move. This one doesn't move. We're okay with this one. Mr. Morris hasn't woke up too good. All right. I'm going to collapse this. I'm going to expand this one. and sketch 4, right click, edit the sketch. And we're going to change this dimension here to 0.5, green check mark, finish the sketch, and we're happy now. We're happy. Okay. We got to make one more hole to satisfy the bottom row. But notice this circle here, this hole, is not on the same center line as this one. So this one's okay. And so are these now. Now I like to go ahead and start 2D sketch, start 2D sketch, click on this face. You might need to pan, go to point. Look, I'm going to hover. If you don't see that center point, you can touch off on the edge of the circle and you'll see the little green dot. Don't click. And I'm going to just come over here. You see a ghost image of a line. I'm going to click. Right click. Okay. Now, I know for a fact that I moved at the last second. Yours might be right on it, but mine's not. I moved because I'm old, right? My hand got shaky. All right, but there's no worries here, right? Go to dimension, click here, here. What should this dimension be based on the drawing? 3, right? Select the green check mark. Now, Mr. Morris messed up because my hand moved at the last second. Remember, I was trying to stay on the center line with it, but my hand moved. But that's okay. Just type in 4, 2, 2 here. Select OK. Finish the sketch. Finish the sketch. And what we're going to do is go to hole. It's a threaded hole, no seat. What size is the hole this time for E1? We'll find E1 on your table and go all the way across. What is the diameter of the hole? 9/16. Is that what you said? 9/16 is the diameter of the hole. What's the decimal equivalent for 9/16? That's the fraction, right? Type in 9 divided by 16. Type in 9 divided by 16 on your calculator. What is 9 divided by 16 with your calculator? No one has a phone? All right, I'll do it. .5625, right? So I'm gonna have to go up here. I'm going to scroll. There it is, 0.5625. 9/16. 12. Do we want 12? Yes, we do. Unified National Course. The classification of fit is 2B. We want a right-hand thread, and the threads go all the way through the part, or the full depth of the hole. Select OK. All right. That's a beautiful thing. We got the first row done. Now we need to do the second row. So we're going to do the second row now. We're going to go to Start 2D Sketch. Thank you. Go to Start 2D Sketch, and click on this face. Where do we go next? Point. Just click anywhere, sorry, in this general location. Do a right click, okay. Go to dimension. I'm gonna click here. I'm gonna click here. What dimension should that be? Now, here's the thing. You're not you're not given a physical dimension here. You have to go look at the whole table to find it out. What is the Y dimension for F1? Sorry. What is the Y dimension for F1? It's 1 inch. Now we also have to do our horizontal dimension. And we know that one. That should be 0.375. All right, we're going to select the green check mark. Finish the sketch. And we're going to go to hole. We want it to be a threaded hole. We want no seat. But this time we're going back. What is size F1? It's 1/4 28. So we're going to go back to 0.25 again. There's 0.25. But be very careful. We don't want a coarse thread this time. We want a fine thread. So a fine thread means you have more threads per inch. If we have 20 threads per inch, that's a coarse thread. Then 28 threads per inch is a fine. So we're going to come down here until we find 1/4 28. There's 1/4 28. It's going to go the full depth of the hole. Select OK. All right, we got that hole done. See? By the way, you can use your view cube up here to manipulate your views. I like to work in the isometric view a lot. Okay. We're going to go to start 2D sketch, start 2D sketch, and click on this face. Place your point. Now I can hover, right? I'll show you a little trick. If I hover here and drag out and move slowly, and then touch off this one, sometimes if you're lucky, well, Mr. Morris, not so lucky here. I'm going to do a left click. Come off the screen, off the part, do a right click, okay. Now let's dimension that one. That's okay, 1 inch is okay. Now let's dimension this dimension horizontal. And that should be 0.938. Select the green check mark. All right, making good headway here. We're going to finish the sketch. And we're going to go to hole. We want it to be a threaded hole, no seat. This time, what is the size of the thread for G1? You go to the whole table and find G1. What is it? 5/16, right? That's 0.3125, correct? Just take 5 divided by 16. What is 5 divided by 16? Y'all know how to use your calculator on your phone? What is 5 divided by 16? 0.3125. Okay. We want to be 2B, right hand, threads go all the way through. Select OK. All right, now let's go to start 2D sketch, start 2D sketch, click on this part. All right, I'm gonna get back in the isometric view. Point, I'm gonna put a point right here. I didn't do the inferred line or hover this time because with me, I can almost do it just as fast by not doing it that way. Make that 1. And what is this dimension here supposed to be based on your drawing? 1.562. Click on the green check mark. Finish. Select hole. And this time we have to look at H1. What is the size of H1? It's 3/8. So 0.375 is 3/8. And again, that's H1. What's the number of 24? I'm going to come down here till we get to 24. The threads go all the way through. Select OK. All right. Looking good so far. Now, start 2D sketch. Start 2D sketch. Click on this part. I'm going to put a point. I'm going to hover. Dimension from here to here. That should be 1. Check mark. Now we have to dimension from here to here. And this is going to be the 4th hole, which is 2.250. Select the green check mark. Finish sketch. Finish the sketch. All right. Now we're going to put a hole in here. What size hole should this be? Well, it's I1. If you go to the table and look at I1, you'll see it's a half 20 UNF. Okay, that's easy, 0.5. And there it is. That's a half 13. But that's not what we want. We want a half 20. There's a half 20 right there. There's a classification of fit going clockwise, full depth. Okay. Now, Mr. Morris made a mistake intentionally again this time with that hole. Here's what we need to do. That dimension is not 1 inch because if you look at it, it's on the same center line. This is not supposed to be on the same center line with these. So we go find that hole. Look, here's how you make the fix. Expand it, do a right click on sketch 10, edit the sketch, and I want to change this dimension here to 1.094. And I want to select the green check mark. Finish the sketch. Finish the sketch. Now that's correct. Okay, that's correct now. We have one more hole to do. We're going to start finishing this up. Start 2D sketch. Start 2D sketch. Click on this face. Go and grab the center point. You can hover if you wish. Dimension, I can do here, here. That's correct. And I'm going to dimension from here to here. What should this dimension be? 3, correct? Type in 3. We were pretty close. Finish the sketch. Select hole. And again, there's tapped hole. The seat, there's no seat. And J1 is 9/16. You remember what 9/16 is? 0.5625, and we want fine thread, so 9/16 18, and we're going to say okay, and everything is good in the world. There's our holes. Now we need, if you look at our drawing, do we have rounded corners? We do, right? That's called a fillet. So we need to round, what we need to do is we need to round this corner, and this corner. Do not round this one. There's a reason why we're leaving that a sharp 90. So go to fillet, and we're going to make this 0.25 is the radius. That's the radius of the fillets or the rounds. Actually, technically, it's more correct to say round than fillet with an external corner. When you do an external corner, it should be a round. Internal corner is a fillet. All right, look, I'm going to click on this edge, click on this edge, click on this edge, and I'm going to select OK. And if I come back up here to my view cube, you can see they were pretty good shape. I said, do not do this one. Now over here, Mr. Morris, what is this area here going to be used for? That's going to be used where you can put your initials, okay? And you could put, if you wish, you could put, you know, like a hole right here. You can make a keychain out of this if you want to. Something you made. All right. So now we need to save this. We haven't saved this at all. Go to File, Save As, and this is what we're going to call it. Thread gauge. Hang on just a second. Hang on just a second. I've got to figure out what we'll call this. Hang on 1 second. I'm almost there. I want to see what to call this, okay? Okay, we're going to call it OER7. Okay. All right. So I'm going to go back. I'm going to stop the share for a minute. We're still recording though. So I'm going to go back in and I'm going to share the screen. So we're going to go to File, Save As, OER, Thread Gauge, 2024. OER thread gauge 2024. OER stands for Open Education Resources, and this will count as an assignment. So do a save, select save. When you do that, look here at the top of your browser. It has changed your file name. Okay. Now, this is the default. This is the default color or material, which looks kind of ugly. So if you go up here to the browser, the file name, select or do a right click and go to iProperties and go to physical and go where it says material generic. Mr. Morris always likes to use steel alloy, even though the part that we're going to be using is aluminum. So if you want to use aluminum 6061, you can, but I'll just show you what that looks like. It's not really that pretty. So I like using steel alloy only on my drawing. I still call out aluminum to make it out of aluminum, but why? See that sheen or shine to it? It looks like a piece of metal, right? I am a file, save this. All right. Congratulations, you have successfully finished your 3D part. Now we got to make our drawing. Our drawing looks like this. This is what our drawing is going to look like. Okay, the handout that I gave you. So here we go. I'm going to go to File. Is everybody, raise your hand if you're with me. I'm only seeing one hand go up. Y'all too tired to raise your hands? Nobody else is with me? All right. I'm going to get into a habit where I might start putting y'all in groups of 2 so you can help one another when you get stuck. Because I know I'm making a video is hard. But you can watch the video again. All right. I'm going to go to File. Go to File. Select New. This time we're not going to select Standard IPT. We're going to come down here and select ANSI, which is American National Standards Institute, IDW, Inventor Drawing File. DW is the abbreviation for drawing. I is Inventor Drawing. Click on this. Click on Create. Now, I don't want to use this size sheet. It's very, very big sheet of paper. So what I'm going to do here is come over to the browser, do a right click on sheet 1, and come down here, edit the sheet. Edit the sheet. We're going to select the size, arrow down, select size A, and we're going to make it portrait, and we're going to select OK. So now your border or your drawing looks like this. Now we want to bring in the part we just modeled. So go to base. Okay. And just select OK here. Now, if you move your cursor near the geometry, you'll see a red phantom box appear. Hold down your left mouse button and you can place that roughly where it needs to go. All right. I'm not going to show an isometric view with this one because we're going to run out of real estate if we do. We need to make our whole table. If you look on the drawing I gave you, there's a whole table at the top. How do you make a whole table, Mr. Morris? Well, before we do that even, what I want you to do is I'd like for you to go to annotate right here where it says annotate. click on annotate, and come over here in the middle of your menu bar and go where you see the crosshairs, which is a center mark. Click on the center mark, and you can zoom in and out. You can zoom in close. You can pan. I want to click on the very edges of these holes. Do a right click, okay, and I'm going to zoom out. All right. Now, watch very carefully, please. Over here, where it says parts list and whole, this is a whole table. Click on whole table, and then come down here to your view. Click on whole, come down to your view, click. You'll see this little strange little dot. Part of it's black, part of it's white. What we're going to do is move it down, and we want to snap. We want to snap to that sharp corner. That's the reason I left it. Click on that sharp corner. Okay, do a right click, create. Okay, and we're going to place this right here. Okay. All right, hit enter. Okay. Hit enter. Now let me think about this for a minute. It did not do what I wanted it to do. So let me hit the undo button. Hit the undo button. It's been a while since Mr. Morris hit the undo button twice. All right, so I'm going to try this again. Click on the hole, move down, click here, and then snap. Now, the one mistake Mr. Morris made was this. What does it say right here in the lower left-hand corner? Lower left-hand corner, read out loud what it says. Select hole edges or create from the right-click menu. Okay, I'm going to select these holes, the edges of the hole. So this is the edge of the hole. Not that, but it's being finicky. Click, okay, click, 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 click. Now do a right click, create. Now place your table. Click about right there. Were you successful? I'm going to do it again. Raise your hand if you got the table. Only one person got it. All right, watch. I'm gonna undo it. I'm gonna undo. I'm not worried about the order of this here. Okay. Don't worry about the holes, alphabets being out of order. Okay. It's not going to agree with your whole table on the drawing, if that's what you're asking. All right, I'm going to undo this as if we've never done any of this. All right, look. Everybody right here? You here, Emery? You're working. Okay, well, working's good. Do you have the geometry on the? I'll come by and help you right after we get done.
I was trying to catch up.
Well, we're making a video here, so you should be able to watch it and replay it, rewind it, you know what I mean? So you'll be able to do that. Don't panic. I'm not great. I'm not collecting this right away. So don't for it. We're learning right now. I will grade it eventually. I will grade this eventually, as well as the T-slot stuff. Okay, watch carefully. You know, sometimes it's best just to stop and watch. All right, so I'm gonna go to whole. See right here where it says whole. I didn't mean to go so fast, by the way. Move my cursor near the object. You'll see a red box appear. Click, and then look, we want this indicator to, actually, this is the origin of the part. We're gonna click right there. All right, now down here in the lower left-hand corner, it gives me a note. It says select whole edges or create from the right-click menu. Well, I did this. I zoomed in and I clicked on the outer part of the holes. By the way, this symbol represents tapped holes. Then I'm gonna do a right click, create, and I'm gonna place it right here. Did anybody in the class get this to work? Okay, y'all don't like to raise your hand. That's okay. All right, now I don't want the letters to be on the plate. I don't want the letters to be on the plate. Mr. Morris, how do I move the letters? Look here. When you put your cursor on the letter, what happens? What happens when you put the cursor on the letter? You see a green dot appear, right? If you hold your left mouse button down on that green dot, you can drag your part off. I would like for you to arrange yours like the way you see it on the drawing. You just move your cursor over the letter, hold down your left mouse button over the green dot, and I'd like for you to do exactly what is shown here. I've been trying to put my letters between the two holes so that when I did my other dimensions, it won't interfere. See, I'm gonna put this like between those two holes. And I'm trying to keep them lined up. It makes the drawing look much neater to do that. I got to zoom out some up here, same thing. How many of y'all were able to do that? Okay. Now, all we have left to do really is add our dimensions and fill out our title block and save the PNG file and the DWG, I mean the PDF, and submit this if you're ready to submit today. If you're not ready to submit today, don't worry, you have time, but you know, we need to make sure that we go back and rewatch these videos. On the days when we're working in the machine lab, that's a good day to go back and look over the video. Like, for example, group 1 didn't go to the machine lab yesterday, right? So group 1 is going to go to the machine lab on Monday. Well, actually, on Wednesday, excuse me. Monday is lecture. And then the other folks who went to the machine lab, that's a perfect opportunity to catch up on your CAD work or any work. because you have me for 4 classes. All right, now, what I want to do now is I want to start dimensioning this. Go to dimension, the dimension tool at the top left-hand corner, and watch. I'm going to click here, and I'm going to drag a dimension down like this. Now, I don't want it 2 decimal places. I want it 3. So here's how you change it. Under Precision and Tolerance tab, come over here and select 3 decimal places. Select OK. Watch. Click here, drag it. Keep the spacing between dimensions uniform. The spacing between them, keep them uniform. Click. Make it 3 decimal places. Select OK. Okay, you can always pan during any of these things that you're working on. You can always pan. Click on this edge and the center here. Change the 3 decimal places. Okay. Just keep doing that. Now, if you start to run out of room, here's the beauty of this software. I'm going to do a right-click OK. I did a right-click OK because I've got to move my geometry. Look, here's all you got to do. Hover near the part until you see the red box. Hold down your left mouse button and move it up. And guess what? Your dimensions move with it. I'm going to go back to dimension again. By the way, if you want to move your table, just hover over the table till you see the 4 arrows. Hold down the left mouse button. You can move your table where you need to move it also. I was just trying to give myself a little more room. All right. I'm going to put this dimension here and here now. And by the way, I forgot to do 3 decimal place. If you forget to do the 3 decimal places, just double click on the dimension, double click on it and change it to 3 decimal places. Say OK. All right. Now, so far so good. I want to add some dimensions over here. Look here. Now I'm going to add one more dimension. I did a right click OK. I did a right click OK so I can move this again. Look, I can move it out here if I want. See? If you're running out of space, move it around a little bit. I'm going to add a dimension right here for this rounded corner. See that little radius symbol up here? And we can make it, I'm going to leave it 2 decimal places. I'm going to change the text. Click on the text tab. And I'm going to type in parenthesis 4x, close parenthesis. That means 4 times. Now, right click. Okay, now what some of the students did, they didn't realize that this corner here is supposed to be a radius like that as well. Some students just left it as a sharp. I'm okay either way, but it really should be a rounded corner. All right. How many of y'all were able to finish that? One person? Okay. Wow, a lot of hands are going up. I'm really proud of you. But I'm not unproud of you. Is there a word, unproud? I'm not disappointed in you if you didn't keep up, because it is a lot. Okay. You'll get a chance to go back and watch the video again and fix whatever issues you may have. I may come back as soon as this is done. I'll come around and check your work. All right. We need to fill out our title block. This is pretty easy. Go over to the browser, do a right click on it at the top on the file name, come down to iProperties and the summary. The summary is the title is going to be OER thread gauge. OER thread gauge. Subject is CAD 140. The author is me. The manager is, actually, you're the author. You're the author, but I'm the manager. The company is Virginia Peninsula Community College. You see this line here? Anything you put underneath this line, like category, you could put in here classwork if you want to. Keywords, comments. This was a great assignment. That's not going to show up on your title block anywhere. But is classwork one word or two words? I'll make it two words. All right, go to project. Mr. Morris's spelling is not the best anymore. I used to be really good at spelling. Designer, you are the designer. Your last name, uppercase letters. You should be using uppercase letters for everything. Engineer, you are the engineer. Put your authority is Mr. Morris. Put Morris, not Mr., just put Morris. Status, go to status, please. Checked by you. Click on the date. Engineer approved by you. Click on the date. Manufactured approved by Morris. That's going to be me. So it's you, me. Okay. Let's see. Apply. And before we leave this box here, go back to general for a minute. Summary, I'm looking for something here. Project. Okay, under project, where it says revision number, I'd like you to type in the letter C so we don't make Forrest upset. Apply, close. Now, that's what your title block should look. Some of y'all just filling out part of it. I took off points. You can fix it. You can fix it, but I took off points for it. Let's see. The other thing I want to change here is the title. So if I'm going to go back and change the title, right click on this, iProperties, summary. The title I want to be OER thread gauge 2024. This is a new design. This is a new design. Apply, close. All right. Now do a file, save. Save. All right. Look how nicely our file name fit in the drawing number slot there. I hope your title block, if you did this, that's a nice, if you did your drawing, it looks like mine, you did a nice job. All right, you need to pat yourself on the back. This was not an easy drawing to do. And you should be keeping a portfolio of your work. Somewhere you should be keeping copies of your work. So when you get ready to make your portfolio later, you'll have a nice portfolio. Okay. All right. Now, Mr. Morris, how do I print this? If I want to print this, to the printer, go to File, go to Print. Now I want to do a preview here first. Oh, Lord. See, I know that's not what I want. I do not want that. See how big the margins are here, and it's going off the page. How do you fix this? If this is perfect, I'm glad this is the way it came up. You're going to close. You're going to go back to File, Print. Now watch carefully. How am I going to fix that? Rotate by 90 degrees and do a best fit. Rotate by 90 degrees and do a best fit and do a preview. Look how nice that looks. Okay. Look at the margins. Nice uniform margins. Okay. And we're going to print. Now, this is where you stop, because I don't want you, unless you want to send yours to the printer, you're welcome to. You want to send yours to the printer, take it home and show it to your parents, you're welcome to do that. Select OK. Mine's printing to the printer. Now, if you want to save this, this is important, because this is how you submit your work. This is how you submit your work. Watch. Go back to the part file right here, lower left-hand corner. Go here. How do I submit this? This is my 3D model. Here's how you do it. Go File, Export, right here, PDF. Oh, no, I'm sorry. Go to Export Image. Sorry, I got confused there for a second myself. And the file name here is OER Thread Gauge 2024. See, it says PNG. We're exporting. Save. Now, guess what? You can use this picture now. If you were a student working on a research paper and you're doing some design work, you can include these figures in your Word document. You can include them in PowerPoints. You can include them in Excel. Why? Because it's a PNG file. All right. Don't forget where that PNG file is, because you're going to submit that here shortly. All right. Now, I'm going to go over here to the ID lower left-hand corner, click on the IDW file. How do I change this to a PDF, Mr. Morris? Because not everybody has the software. They can open it up and make changes to it. They can't. They don't have the software. But I want Emory. Emory's in California. Mr. Morris is in Virginia. Emory doesn't have the software. All right, Mr. Morris, what do you want me to work on? I said, okay, well, at least study the drawing. Well, I can't open the drawing because it's made using the IDW file. How can I get a copy of the drawing? File, look, export, PDF, right here, PDF. And make sure you know what directory you're saving it in. Save. Any questions? Now, what do you submit? You have two submittals in the same assignment. It's the same assignment, two submittals. I will create that for you in just a moment, that you can submit that. And I have time today. I might be able to grade it before you leave. So I'm going to go ahead and stop my video here. Okay. Stop my video. And for my online students, see you soon. Take care. So I'm going to stop the recording.